Hey everybody, Scott Mann here, noisechop.com. I'm doing another TouchDesigner StreamDiffusion tutorial. This one goes over how to build a generative AI rendering network using .simulate's StreamDiffusion talks. For the purposes of this tutorial, you should probably go watch your first StreamDiffusion tutorial, which I did recently. I'll put a link to it in the show notes and a link to the download, but it is behind a paywall. You can get it for $5. It's the best $5 you'll ever spend. Thanks to .simulate for this amazing tool, which allows us to do generative AI from inside of TouchDesigner. This is the whole network right here. I did sync a couple things into bases, and I'm going to go over some, how to just save out your own custom talks, because everybody should be doing that if they aren't already. It's a pretty simple network. It'll take a little time to get through, but let's get right to it. Okay, so here we are in an empty network. I'm just going to use the internal audio track, TouchDesigner audio track, which we all know and love. I thought about using something different, but we all have this. It's simple. If you have a file that you'd like to use instead of this, just use that instead. I just figured, hey, this is I want to make this as simple as possible. So here you have it. Let's see, I'm going to copy the audio file, and then I have for this is an audio device out chop, and I have the level set properly here. So obviously you can just get the audio device out. I'm going to turn that off because it's making me a little crazy. But I will need it from time to time, so it's there. So the first thing you're going to do is drop a math chop, and you're going to go to combine channels, average, and this is just a way of mixing the two channels together. So you have only one channel to deal with. You can do this in stereo and have different channels doing different things. So the left channel is doing one thing and the right thing just by splitting the channels. And you would use all these same concepts. It would just be twice as much work. So again, we're going to try to keep it as simple as possible. After that, you have a mono audio playback situation happening here. You're going to drop an audio spectrum. So now you have a spectrogram of the audio. To make it as efficient as possible, you could drop this down to 4096 or even lower. This just makes it a little lower resolution, but as you'll eventually see, we don't really need too much data coming out of this. This is more than enough. I tend to just go ahead and boost the high frequencies. So under high frequency boost, I put it to 5 just because high frequencies are much more spread out over the spectrum than low frequencies, which are more concentrated. So you just kind of want them to be even coming out, because it just gives you a little bit more action to play with when you're converting this spectrogram into a visual. So the next thing we're going to do is a resample, and that is because this thing is coming in at 44,000 samples a second, which is a lot. I've done this sort of network with like 8 to 10 audio channels, and it can handle it, but we just don't need that much data at all. We only really need 30 frames per second. In fact, good thing that came up, because I'm running my network at 30 frames a second, because StreamDiffusion running at its best will give you about 30 frames a second. So there's no reason to push TouchDesigner any harder than that, since your ultimate output is only going to be 30 frames a second. It doesn't really give you any more detail to have it running at a different speed. So that's our sample rate. We want to turn time slice off because we want to get the whole spectrum here. Now, I want to sample it at a new rate and a new interval, okay? And I'm going to set up a constant chop here. And this is going to govern our sort of how many samples that we're dealing with per frame. And I'm going to set that to 1,000. If you're having performance issues, you can turn this down. That's kind of why I put it out here separately. But let's move this out here a little bit. And then we're going to drop this. I'm going to set this to absolute. So this just means starting at 0, absolute 0, and going to 1,000. Okay. So our sample rate is 30 frames per second, and we're dealing with 1,000 samples every 30th of a second. So samples in this case sort of has two meanings. So you can see that it got more detailed, right? When it was down at like, if this is set to 20 or whatever well, I don't know what the default is. Let's say we set it to 10. Gosh, I mean, even that would probably be enough detail for you. But let's just leave it at 1,000. Most of your systems that you're running will easily be able to handle that. And eventually what we want to do is kind of recreate this with in a graphics form. And the way I'm going to do that is with an instancing system. So I'm going to put in a pattern chop here. Pattern. And this guy is going to be a ramp. And its length is going to be 1,000, which it already is, but I want it to be referencing. Oh, no, yes, that's right. You can copy and paste this guy and just set the amplitude of this one to 0. So eventually what we're going to have is a bunch of vertical lines running from 0 to whatever the amplitude of this is. I'm going to set this to 10 for now. I'm not exactly sure that's where we'll end up. But from 0 to 10, we're going to have 1,000 vertical lines, and each line is going to get its length from the spectrogram. Okay, that's the sort of general overview. I'm going to drop a rename, copy and paste it a few times. This one is going to be TX. This one is going to be TY. And this one is going to be scale. Let's hook those up. Okay. So now we have our X position, our Y position, which is always going to be 0. We're just going to put it right along the X-axis. And this is the length of our line that's going to jump up and down. Let's merge these two guys right here. So these will be sort of this is our XY position of our instances. I'm going to drop a geo. This is all the normal stuff. Hopefully, this is sort of autopilot. So I'm going to go into the geo and I'm going to make a line. SOP. Boom. Right now, that line is going from 0, 0, 0 to 1, 0, 0. So this is X, Y, and Z, right? I want a vertical line. So I'm going to make it go from 0, 0, 0 to 0, 1, 0. So it's kind of hard to see here, but we basically have a vertical line. Oh, no, I'm sorry. We're going to make it go from -1 to 1. So you can kind of see that there is a white vertical line sitting there. And let's just drop a null in here and turn on view and render. And then I'm going to drop a camera just like we always do. Here's our geo. Let's give ourselves a little more space. A material. I'm just going to use a constant. Just drop that in the material. And a render. And not much to see here. Let's make the let's make this 512 by 512 because that is the resolution that is most comfortable for StreamDiffusion to handle. And remember that we're rendering, almost 30 frames a second. It has to draw something every 30 frames, so we've got to be as friendly to it as it can because getting that thing to run as efficiently as possible is key. All right, let's put a null here because we're good people. We'll call this null pause, in keeping with tradition. And I'm going to go into my instancing network, turn instancing on, and drop this onto the translate op. And then translate X is going to be TX, and translate Y is going to be TY. And now you can see we have a bunch of vertical lines going from 0, 0, right? So it's going from 0, 0, and then X goes up, and Y just stays the same. Now, since my lines are going off the screen, I'm just going to back my camera up until I can see them all. Okay, so there they are. I've got it so that it's just going to the end. Drop a null here. This is going to be null underscore scale. And that has way too many samples. Why is that? No interpolation. Is that the problem? Oh, I have this set to seconds and it should be samples. Okay, so just to go over that again, you got to make sure, obviously, that all of these guys have the same number of samples in them, right? So this has 1,000 and this has 1,001. There's another thing I forgot to do. Go back to your resample, and where it says end, just drop a -1 there. Okay, so because this goes from 0 to 1,000, whereas these just take the absolute value of the number of samples. I guess this one starts from 1 and this one starts from 0. So subtract 1 from your constant value there, and now you should have 1,000 samples per chop, and then you won't get the dreaded instances need to have the same head count error or whatever it is. This guy, null scale, is going to go into scale Y only. That's wrong. Undo. It's got to go in the op. And then turn on the scale for just Y. So it's stretching that line on the Y-axis for us based on these values, right? And there you have recreated a nice little spectrogram for yourself. One thing I'm going to do, let's see, right away is it's a little jumpy, bouncy for me. You don't have to do this, but I'm going to stick a filter in here. Filter. And this just kind of averages the data over time. So right now the filter width is a second, so it's looking at the average of these values over the course of the previous second, which is much too slow. Switch this to samples and just set this to like 3. So it's going to look at a window of about 3 samples, and it'll make it just a little less jumpy. You can fiddle with this value if you want it to change, but if it gets too soft, then your audio-reactive video won't look quite as audio-reactive. Then I'm also going to stick a math in here. And go to multi-add and just, you can kind of pop open your render window here and just turn it up so that you're getting a little more action there. I'm just increasing the amount by which we're scaling these lines up, right? So that's how you build your basic sort of spectrogram rebuilt. And then You have a nice little visual here, which is jumping around and is responsive to various frequencies. And it's sort of a great point of departure. You could stick this on the side of a geometry if you wanted to do that. There's a million ways to sort of use this basic network. You could change this pattern. Instead of running it flat, you could run it as a sine. You need some amplitude, right? And then it's on a curve. So there's all kinds of ways to play with this, but I'm just going to do the simple version for now, and then you can get in when you get your network set up and have fun messing around with it. Right after this, I'm going to put a mirror. It's going to go in there like that, and I set the rotate to -90. This is sort of a cheat. I might squeeze that down a little bit. So I'm going to go back to the amplitude of my pattern, which it defines how long a reach should be, this line. So if I can stretch it out, or I can shrink it down, right? You can see that happening. I'm going to set it to like, I don't know, 8. So I've got the amplitude of my pattern X set to 8, and my camera is 25 units away from my graphic. So I have this nice little mirrored spectrogram. And then I'm going to drop a transform rather. Copy and paste that. And I'm going to put one a little bit up. It's probably too much. I put it up to 1.5. And this one a little bit down. And then I'm going to scale this one down a little bit. Just so I have, now I got 2 versions. I'm double dipping on my mirrored spectrogram. Then I'm going to add these together. Boom. Like that. So now I have 2 across 2 separate lines. And then I'm going to run it into a feedback network. So I'm going to drop a null here. Just so we have a little something where we can, a little stopping point in here. Drop a feedback, probably familiar to most of you. I do this with an add. This goes, well, first you want to drop a level into the bottom half, and we're going to add those 2 together and drop our add back onto our feedback top. So now it's just adding all the previous frames because I haven't changed anything in the feedback network. So I'm going to do the thing that we always do, which is drop this down to like 0.9, the opacity. So over time, these will fade out, right? This is a common technique. I'm also going to add a transform in here, and I'm just going to scale it up a little bit just for fun. So it's kind of it's taking the whole thing and scaling it up over time as it fades out. You can add or remove this later as you like. And then I'm going to stick a null right here. And now I have the most basic of feedback networks, and I'm going to highlight all of it, right click on the network, not on any particular operator, and say collapse selected, which is a great trick that most of you probably know, but hey. And then I'm going to call this feedback, and I'm going to right click it. If you want to save this talks, you right click it and just tell it to, where is it? Save component.talks. Okay. And now you can just save this into, I have a big file full of, a folder full of talks operators that I made that I reuse all the time. Here it is. So here's all the ones that I regularly use. it'll name it whatever you've named your operator and just save it in there, and then you can drag it out. I will do that now so we can use it again. Save feedback.tox. I'm going to save it into my tox files. Boom. And now it'll be there for us because we actually are going to use that same series, the same operator on the other side of the AI rendering engine. Okay, so now I'm going to put a displace. And this is going to go into there. And I'm going to drop a noise. And let's go to the input here just so I can get the resolution. My output from the noise is going to be just the noise. I just did this to get the resolution that I want. Turn off monochrome. And so now it's heavily displacing my graphic. I'm going to turn the displace weight way down to like, I don't know, 0.03 or something like that. So it's just displacing it a little bit now. Okay. So getting a little more advanced, I'm going to figure out a way to get the kick drum, just the kick drum, to trigger a random number every time that it hits. And this is a hugely useful technique in lots of different ways, but especially when you're doing audio-reactive work with the generative AI, because you want to be able to change noise seeds really fast and all the time, and you want it to change based on what the music is doing. The most obvious thing in this case is the kick drum. Oh no, I'm sorry. I'm using the snare drum for this. So let me just turn this on for a second. Kick drum is the low drum. The cat. That one on the backbeat is the snare drum. I'm going to turn this off because it's really hard for me to talk while the audio is running. God. And off of your spectrum right here, just drop an analyze, chop. Wait a minute. I missed an operator. Let's just disconnect this for a second. You are going to need your analyze. The first thing you need is a trim. And trim is just a way to chop out some of the samples that are coming through. So if I look at this, crap, I don't want to take this off of here. Sorry. I want to take this off of my resample because this is going from 0 to 1,000 because we resampled it. This one, oddly, the audio spectrum goes from 1 to 15. I don't know why this is. There's innumerable frequency bands in here that it is measuring. It seems to me to be arbitrarily just going from, this should really be from 1 to like 22,000 would be the maximum frequency that it could represent here, which I think it is doing. But the resampled one is fine, and it's a lot less data. So, sorry, I just had a call from my cousin. Okay, so going from 1 to 1,000, we really just want to chop out the stuff where we clearly can see that the snare drum is responsible for most of the energy. So you can see that you're getting all of this activity when the snare hits between like really 600 and 1,000. I'm going to set it to absolute, and I'm going to take this from 800 to 1,000. That's just what I found seemed to work. And then plug that into your analyze. Okay, so now we can see if I turn this on, we're getting a nice bounce every time the snare hits. Average is good. There are different ways of analyzing that, but I think average will be fine. If you plug this into a trail, you can see that it's catching that snare drum pretty reliably, right? That is much higher than anything else, and that's really what we want. We're trying to isolate the snare drum from the mix here, and it looks like we've done that. Let me turn this off again. Okay, so I'm going to drop a trigger in here. Now, the trigger is basically asking you for a threshold, and when the signal that's coming into it reaches a particular threshold, it will give you a whole series of values. Right now, the trigger threshold is 0, so it's just kind of always triggered. I'm going to go into my envelope in here. If you want, this is basically an envelope generator. If you want to read about envelopes, they have an attack, a decay, a sustain, and a release. I'll talk a little bit about it, but I'm just going to kind of blow through it because it's probably familiar and you could figure that out elsewhere, but we will look at it for a second. I'm going to make the attack length 0, the attack shape linear, the peak level is going to be 1, and the peak length I'm going to set to 0. So this is just the super quick version of the trigger, right? It's as short as it can possibly be. And I'm going to set the trigger to like 0.35. Wait, let's look at the trail. It's not 0.35, it's 0.035. Okay. So now I'll turn the audio back on for a second. So now you can see we have a reliable trigger whenever the snare drum is hitting, right? If I messed with this threshold, now the threshold's out of range. You can see it never reaches that value, so I'll undo that. If I set it to be too low, it's going to get triggered when you don't want it to, because some of these values are getting up above 0.25. I'll set it even lower. Now it's getting triggered too much. I haven't isolated the snare. I only want the values that are crossing that 0.035 threshold. Oh, I haven't turned all this off yet. Whoops. I meant on... for your attack, you want to zero everything out and then set the sustain portion. I have to turn this off. I can't talk with the audio going. You want the sustain, the minimum sustain, the release, everything linear, everything 0 except for the sustain level, which I'm going to set to 1. Okay, this is the level that the initial attack is going to get to. So you can see as I turn this down, I could even just plug this also into my trail chop, which is kind of useful. Wait a minute, that's not right. Peak level. Peak level is what it initially hit. So this is just the attack phase. I do want the sustain level to just be 0. If I turn this up and I give it a sustain length, you'll see it'll trigger and immediately drop down to your sustain, and it'll sustain there. So if I shorten my sustain, you'll see my little sustain will get shorter. But really, all I want to do is trigger, is get this one value to trigger a chop execute for me. So that's what I'm going to do. Drop a null here. We're going to drop a chop execute and drag our null into the chop execute and turn on the off to on script. And I'm just going to edit. This is a very short script. We can check to see that it's working by just saying print snare hit, right? And then I'm going to hit Alt T to get to my text port, and we can see that yes, indeed, every time we hear a snare drum, our script is firing. So now we don't want it to just print something for us, we want it to do something. So I need to import random. This imports the random library. And then I'm going to say randint, that's just the name of our variable, equals randint 1 comma 1000. So I'm going to get a number between 1 and 1000. Got a little typo there. Rand underscore int equals randint. So this is just going to give me a random integer between 1 and 1000 every time the snare drum hits. And then I'm going to drop, oh, it's not happy. Why isn't it happy? Random dot randint. Okay, now the script is happy. Randint equals random dot randint without the underscore, 1 to 1000, and drop a constant chop. We're going to call this constant underscore seed because we're going to use this to change a noise seed. And right here, we're going to say op constant underscore seed dot par dot constant 0 value equals randint. Okay. So now every time we get a snare hit, we get a random integer, which is fun. And then we're going to take this guy over. Well, let's just drop a null first. We can put this anywhere we want. It's going to be affecting these guys over here. And I'm going to take this value and drop it into my seed of this noise. Okay. So now every time the snare hits, it changes the sort of shape of my noise. And if, you could change the period of this if you want like a bigger value, it'll give you a more, and then if you change your offset and your amplitude, you'll see it more intensely. Copy this and paste it, this noise, because now we have 2. I'm going to also now multiply my output here. So just drop a multiply top, boom, by my my colorful noise that is changing every snare hit. And I'm going to turn this period quite a bit down, actually. I think I liked this better when the offset was 0.5. Let's put that back. 0.5, 0.5. You can adjust these individually. This is probably the more important one. This is the one that's colorizing your generative input. And this is what's going to end up giving you more detail. But we can play with those once we get generative artwork happening. So you drop a null there, and now is when you're going to go get your already downloaded StreamDiffusion 2.6 tox file and drop it into your network. There it is. And we're going to plug this guy into here and start the stream. Give that a second to load up. Let's see. Whoops, I made a mistake. Stop server. You want to turn acceleration on, and I go over this in that other tutorial. Make sure that you have TensorRT running. It really makes this thing run much faster, and then start your stream again. Okay, so now it's kind of working. Default fancy banana. I'm going to turn this on. What if I take one earphone off? There we go. I'm just going to take the cups off. So hey, we have an audio-reactive thing that is not very interesting, and the reason it is not that interesting is that the step is too low. This is One basically means render more times. It actually means do more steps of denoising. My magic number for steps is right around 16. So there you have a default fancy banana audio-reactive piece of artwork. My idea was for this to be like a face, so I'm just gonna say infinite powerful face of nature electronic deity. Okay, so I don't know, maybe for like a trippy EDM thing or something, you know, sort of looks like a face. Now we have a slightly more interesting prompt. Watch what happens if I crank this up. I mean, it kind of depends what you're going for. It's going to kind of look better if you turn the step count down, even though you're sort of turning it up. But what you're basically doing is washing out your input when you do this. You're basically adding so much noise to it and then washing it out that it's not even really changing that much. Do whatever you like. Somewhere between 10 and 20 is what's, you know, if I turn this all the way up, you'll see that it almost starts to look just like my input. If I crank it, it almost is exactly my input. So the higher you put it, the closer it will be to your input, but you get more audio reactivity if you keep it somewhere, you know, not rendering so hard. So again, my favorite is right around 16. Now, that Tox file you saved before, let's get it. Where is it? Here. Tox files. It's called feedback. Feedback.tox. Don't have to recreate all that work. I got it right here. I'm gonna stick this in there. Bring it out to a null. You can obviously do all kinds of post-production and weird stuff on this. So let me just view this. I don't know, kind of interesting, but I actually want to remove the transform from this. The reason I'm doing this is if you look at this one without any feedback on it, it's a little twitchy, you know? So I like to put a little feedback on it just to smooth it out. And I don't know, I guess this is set to 0.9. More like 0.8 for this is good. Whoops. 0.8 for the opacity of your level in here. And see how it's just not quite as jumpy. Another thing I like to do, and this is what you should save this as part of your feedback talks, which you use a lot. Turn down the opacity going in. You'd be surprised how much you can turn it down. You know, if you compare these two, it's like I put it all the way down to 0.3. And this is because since it's looping, the colors are piling up on top of each other and they're getting washed out and too bright. Without this level, that's why you're getting all this white. Because the colors are just saturating into, and they're going probably higher than 1 and becoming just white. So turn down the opacity before you go into a network like this and you'll kind of do a better job of preserving your colors. Don't have to do this, but I like how it makes this guy look a little sort of smoother, right? That's really the whole network. Now the fun part starts. You can take some of your values, and I had sort of a funny prompt going when I made this, where I wrote it down. I'm gonna copy it here. It's beautiful 3D digital collage, deep space, alien, plant, planet, music, technology, disco blast, lighting, skyline, New York, spotlights, joy, flowers, trees. That may be too many terms for it to digest, but I don't know. I think it doesn't read past like the first 8 or whatever. But the more stuff you put in there and the more variety you put in there, it'll make different choices about your network. I mean, you can put, you know, goth warrior princess playing the guitar in here and, you know, see what you get. Now you've got your goth warrior princess rocking out kind of. When you have you know, since we're doing sort of an abstract thing, if you put people in your prompt, I'm going to undo this. If you put people in your prompt, they tend to be warped and weird looking, so you might use more abstract kind of concepts, but you can literally write anything you want in here. You'll see it's kind of staying in this shape. Your random number can be super useful to you in other ways. Like if let's say I took this constant, I know that it's choosing numbers from 1 to 1,000. I could just use that value, or I could just math it and say, hey, instead of going 1 to 1,000, oops, go to 1 to 360. Okay, so now I get a random number between 1 and 360, and I want this. Oh, I guess it doesn't really matter. I was going to say I want it to be an integer, but we can have a float, I think, for rotation. So I'm going to throw this number into the rotation of my graphics. So now it's turning every time. You can do it for both. Make it rotate randomly. And now your shapes will get more varied. You know, this is now what I'm sending into it is this guy. Another thing you can do is take your random seed value and feed that into the seed of StreamDiffusion itself. So now the noise seed, because remember that StreamDiffusion is actually adding noise to your network. And if it has the same seed every time, it's going to add the same noise pattern and give you kind of the same thing. One other thing you'll notice, and this is something I go over in your first StreamDiffusion video, is that this is what is really defining the level of detail you have. So if you turn this up, I'm going to turn the offset up a teeny bit here, brighten the colors, and then if you turn your period way down, you'll see you'll get more detail out of your output. I go over ways in that other tutorial to make mixtures of noise. So you have some areas of intense detail and some areas with less detail. There's a lot of different ways to do that. For now, I'll just kind of leave this at sort of a middling value. But you can see that's pretty cool. One other fun thing to check out is stick a level before it. It's just so interesting to see what this thing does when you mess with the input. Just inverting the input changes the look and feel pretty dramatically, because I think it just completely changes the assumptions of your rendering system based on its training data. So I don't know. It's like there's a lot more flowers and stuff in here. You could even go in between. You could tell this that it wants to be a pencil sketch, maybe. Then you get more sort of a pencil drawing. I think that's kind of less interesting, but you can also intensify contrast, will give you different looks and mess with the brightness. Whatever you want to do, stick another mirror in here and you'll get a perfect symmetry. Which has an interesting effect on it. Right? This is endlessly fun and endlessly entertaining, so be careful about frittering away too many hours doing it. I think that's it for now. That should get you up and running with an audio-reactive generative AI project. Again, I will try to get to your questions in the comments section. Until then, have fun with audio-reactive generative art. Over and out.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner, and creative tech pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private group where Matthew Reagan, myself, and our other industry veteran and pioneer teachers answer your questions every single day. If that sounds cool, click the link in the description to learn more. And if you enjoyed this video, hit that like button and don't forget to subscribe for more free TouchDesigner and Immersive content.